Hello everyone, I am Noor Zainab and welcome to my YouTube channel. In today's video, I am going to tell you that what are capacitors and what is capacitance. I will also discuss that what are the three main factors which affect the capacitance of a capacitor. At the end of this video, you are going to watch a simulation that how capacitors work. A capacitor is a device which stores electric charges and electrical energy. As we know that every electronic equipment has its own symbol, so the circuit symbol of an capacitor is two parallel lines. So in any circuit, if you see this symbol, it means that a capacitor is present in that circuit. Capacitors are widely used in our daily life. They are present in fridges, ovens and washing machines. What is their actual use? The capacitors store energy and they provide the energy when the power is cut off. For example, if a fan is running and suddenly the power is switched off, the fan will continue to run for a few more seconds, and this running, which is going to be for a few more seconds, is provided, this energy is provided by the capacitor. So during power breakdowns, the capacitors provide us electrical energy for a few minutes. So now let's discuss that how capacitors look like in a circuit. Capacitors consist of two parallel metal plates which are parallel to each other, and the parallel plates are joined by a battery by means of wires. The positive electrode of the battery is attached with a positive plate, and the negative electrode of the battery is attached with the negative plate of the capacitor. Due to the positive electrode of the battery, positive charges are induced on the plate of the capacitor, and negative charges are induced on the next plate of the capacitor. The battery is providing us a voltage V. The medium between the two parallel metallic plates can be air or some insulator. This medium is also known as dielectric. So a charge plus Q is induced on one plate of the capacitor and a charge minus Q is induced on the next plate of the capacitor. The accumulation of these charges plus Q and minus Q, their attraction stores the energy in the form of the electrostatic attraction. So there is a mutual attraction between positive and the negative charges. This attraction keeps the charges bound on the plates of the capacitor. In this way, the charges, it is the positive charge and the negative charge, are stored in the capacitor. So after the charges are stored in the capacitor, if we remove this battery which produced these charges, if the battery is removed, the charges will remain stored in the capacitor, and if we need this to release these charges, we can attach this capacitor to a fan or a light and the electrical energy will be released. So here comes the question that how the charges are developed on the capacitor, like how here comes the positive charges and here the negative charges are appeared. So what happens when we attach a battery to the capacitor? What happens is that the battery has some potential difference. So because of the positive electrode of the battery, the negative charges from this plate of the capacitor are attracted towards the positive electrode of the battery, and hence when they are attracted here, whereas the negative charges which are coming from here are transferred to the negative plate of the capacitor. In this way, the positive and the negative charges are developed on the plates of a capacitor. I repeat again that what happens when we attach a battery to a capacitor, the positive charges are present, which are present because the negative charges are removed and are attracted towards the negative plate. In this way, the positive and the negative charges, which are plus Q and minus Q, are developed on the plates of the capacitor. And the medium which is present between these two positive and the negative plates of the capacitor is known as a dielectric. It can be air or it can be an insulator. So what is a capacitance? Capacitance is the capability of a capacitor to store charge. So now, as we know that positive charges are developed on one plate of the capacitor and negative charges are developed on the next plate of the capacitor. So because of these positive charges which are at higher potential and the negative charges are at lower potential, they is a potential difference created between the plates of a capacitor, and this potential difference is denoted by V. So what happens when we increase the voltage? Okay, so if we increase the voltage of the battery, what happens is that the charges which are induced on the plates of a capacitor will also increase. It is the plus Q and the minus Q charge will increase, and because this plus Q and minus Q charges will increase, the voltage, which is the potential difference which is developed between them, will also increase. So I can say that the charge which is induced on the plates of the capacitor is directly proportional to the voltage V which is induced between the plates of the capacitor. In order to remove this sign of proportionality, I will have to put a constant, and this constant which is put in place of this proportionality constant is known as capacitance. So capacitance can be defined as the ratio of charge induced on the plates of the capacitor and the voltage or the potential difference between them. Furthermore, the greater the capacitance, the greater the charge is stored on the capacitor. The SI unit of capacitance is farad. So we can see here that capacitance is directly proportional to the charge Q stored in the plates of the capacitor. The capacitance is directly proportional to the charge Q, and Q is directly proportional to the voltage V. So we can say that more the charge Q which is stored in the plates of the capacitor, the more potential difference V is created between the plates of the capacitor. So now let's discuss that what are the three main factors which affect the capacitance C of a capacitor. The first factor which affects the capacitance of a capacitor is the plate area. The larger the area of the plates, the more capacitance it has, and the more capacitance, as we have now discussed, that capacitance is directly proportional to the charge Q. So more capacitance, a capacitor with more capacitance stores more charge, whereas the capacitor with smaller area has less capacitance and it stores less charge. The second factor that affects the capacitance of a capacitor is the space between the two plates of the capacitor. If there is less space between the two plates of the capacitor, the capacitance is very low, whereas if there is a larger space between the plates of the capacitor, there is more capacitance. If there is more distance between the two plates of the capacitor, the capacitance is very less. But if you decrease this distance, the capacitance increases and the plates of the capacitor will store more charge. And the third factor which increases the capacitance of a capacitor is the dielectric. If a dielectric medium is present between the two plates of the capacitor, the capacitance of the capacitor is increased, and because the capacitance of the capacitor is increased, it will store more charge. So till now we have discussed the three main factors which affect the capacitance of a capacitor. The number one was the plate area. Larger the plate area, the more capacitance a capacitor has, and it stores more charge. The second factor was the distance between the plates. If there is more distance between the plates, the capacitance is low, whereas if we decrease the distance between the plates and the plates become nearer, their capacitance will increase and they will store more charge. And the third factor which affects the capacitance of a capacitor is the presence of a dielectric medium. If a dielectric medium is present between the two capacitor plates, there will be more capacitance and more charge will be stored between the plates of the capacitor.